3.5, you're going to be doing limits, and that's why we reviewed limits yesterday. We approached a constant. When you're approaching infinity, it doesn't make it any more difficult. We're going to be either heading that way or heading this way. We're going to have some function y equals f of x per usual, right? And so when we're talking about, I'm going to make a fake function. We only need one of these graphs. I don't know why I have two in here, but I'm going to make a fake function that maybe the y values are going to go in like this for a while. And if they continued forever, my limit at infinity would be infinity. But let's suppose they start to taper off here and kind of ride along this horizontal line right here. So let's suppose that that kind of bounds it up on the top. And let's give a numerical value. Let's suppose that's up at 4, just for the heck of it. So up at 4, what I'm telling you is that function won't get beyond it. It's a limiting value. So if I were to write this with calculus notation, some people in my second hour walked in and said, we already know this, when they read the learning goal. And I said, you kind of do. You're going to see that you kind of know what we're going to do today. It's just going to have a calculus twist to it, because you've actually found these in pre-calc. The limit as x approaches infinity of f of x is 4. But in pre-calc, what did they call that blue line? And you were able to find it. What did they call that up there? A what? Yeah, it's a horizontal asymptote. They're synonymous. A limit, if there's a limiting value as you approach infinity, it means there's a horizontal asymptote there. Or negative infinity, like I could have had one going down here too, but they are basically the same thing. And in pre-calc, you were taught how to find those asymptotes. So graphically, you're really finding horizontal asymptotes when you're having limits that approach infinity. Let's just write asymptote. I like to say asymptote. All right. Now I'm going to get the I'm having technical difficulty. Okay, I'm covering it. All right, back to this. So they provide the horizontal asymptotes of the graph, which I'm thinking you probably already know how to do from pre-calc. They taught you when you had a polynomial over a polynomial, a way of knowing what the horizontal asymptotes are. We're just going to give it a little calculus twist to it. We're going to give you the y of it as well. So, but let's just pretend that and I think in your unit 0, I had some of this as well. But I'm going to put a polynomial function, rational function up here. Let's suppose, don't write it down. Suppose it's this. And let's suppose on the bottom it was 3x cubed minus 99. If you were asked what the horizontal asymptote is of that, would you remember? Where do your eyes go? Let's see if we kind of remember. Where do your eyes go? To the coefficients of the highest power. Because it's tied, we'd say the horizontal asymptote is y equals 2/3. That's actually also the limit as x approaches infinity of that function. But the y of it is what I want to talk about. What if this was a 5? Then what happens when they're not tied? What's your horizontal asymptote? It's 0, right? And that means the limit of this one as you approach infinity is also 0. What was the deal when the top was higher than the bottom? What would you say the horizontal asymptote is? Infinite. Well, there isn't one, actually. It means it's unbound. So we're going to talk about the y's of this, but I still like that pre-calculus approach of taking a look at where the highest powers are, because it's much more, you get more bang for your buck than doing the calculus method, but the calculus method gives you the why does that method work. So I'm going to do one that way, and it all has to do with this of why those rules work. When you take any constant, what's your favorite number? 6. And divide it by x to any power, what's your next favorite number? 2. As you go to infinity with x, which is the thing on the denominator, what's that going to be? 6 over a zillion squared on your calculator, what's it going to tell you it is? 0. It's going to go scientific notation for a while because it can handle it, but eventually your calculator is just going to say, you know, screw it. I forget when I have this on. It's out there for all of YouTube. I'm just kidding. Anyway, so it's going to say it's 0. Now, Maddie could have said her favorite number was 666 and then that. And she could have said that her favorite power was this. And it's still going to be 0. Because my x is approaching the biggest number you can think of. So it could be a zillion trillion to the 222nd power, and that's just going to annihilate the numerator. Does that make sense to you? So any constant over x to a power is going to go to a 0 eventually. And that's what helps us. Let's go to the next page. That's kind of what's going to help us use those pre-calculus rules in a way that we understand them. So you might be used to plugging stuff in, but what happens on this one is the top's going to infinity and the bottom's going to infinity. So upon direct, like just looking at it, it looks like I'm going to infinity over infinity. If I were to go do a survey out in the hallways and ask every kid, you know, to write on a note card, what's infinity over infinity? I bet you 99% of all people, teachers included, would say that infinity divided by infinity is 1, and it's not. So that's what's weird. We call this another indeterminate form. There are 7 of them in math. We only discussed 2 of them in Calc 1. Indeterminate form. It's not 1 because infinity is not a number, right? It's a destination. So if you're farther along on the top than you are on the bottom, that's not going to be 1, right? But if you're farther along on the bottom than on the top, that's not going to be 1 either. You can't grab a hold of it and say that these are equal because it depends on how far there you are. Neither one are you ever going to get there. It's such a weird concept. But that requires more work. We don't need to look at the graph next. Here's the calculus. If you were to open your book and read 3.5, you'd see a whole bunch of work for a really easy question. I'm going to do it once, and then we're going to, the first year I taught this, I made them do it the long way. Because that's the way the book did it, and I hadn't taught it before. You know what I mean? So I was like, and I taught them it, and it just muddled the issue. They already knew the pre-calc of it. So the next year I'm like, why am I giving them another method when all they really need to know is it's a horizontal asymptote? So I'm going to give you the other method, and I will tell you, and it gives you, the book can't publish the pre-calculus method because it can't just say, look at the highest exponent. It needs a mathematical way. So this is what's always legal in math. Don't write this down. Let's do 8 plus 4, which we all know to be 12, divided by 2 plus 2, which is 4. 12 divided by 2 is 3, and I'm insulting your intelligence, and I apologize, but I want to show you something. It's perfectly legal for you to divide every term here by the same thing. I'm going to divide everything through by 2, and I will get the exact same result. I'll get 4 plus 2 over 1 plus 1. 6 over 2 is 3. Do you see how I didn't disrupt the mathematical integrity of my expression, right? So the thought behind this over here is they say divide the top and the bottom, everything, because it's so legal to do that, by the highest power that you see. That's legal, as long as you do everything. Again, had I not divided but the 8 by 2, then I've got a big problem, right? But let's go divide everything through by this highest power and watch what happens. By the way, you know the answer, hopefully. What's the answer to this? Look, what's the answer? Yeah, the bottom's going to take over, that's going to 0. That's really the best way to think of it, because I think common sense trumps math pretty much universally. This is getting so big, it's going to go to 0. Put that as your answer. But here's the mathematical reason why. If I divide everything through by x cubed, right, the highest power, you'll never do this again, just one time. I hate to just give you rules without telling you where they come from. So even if you just want to watch right here and not write it, that's fine. Look at what happens on that. All 4 pieces, I'm going to do them individually like I did over here with all the numbers. So let's go take a look. As x goes to infinity, what's this going to go to? What's this piece going to go to right here? That's going to 0. As x goes to infinity, this is really 2 over x squared right here. That's also going to go to 0. That will numerically have a 0 on the top no matter what, right? On the bottom, those cancel. That's going to 3. What's this going to? 0 again. This actually is 0 divided by 3, which is and still is 0. But really just look at the highest power. It's in the bottom. It's going to 0. Okay? Makes sense. This one, you should know the answer to this based on just horizontal asymptotes. The highest powers are tied, right? So what's the answer? Negative 2 over 3. You grab where the highest powers are, you grab their coefficients because that's what you were told. And that's great, and we're still going to do that. but here's why roughly. I'm going to write it down really fast now. What's the highest power you see over here? X to the first. So I'm going to divide 3 by x to the first, 2x by x to the first, 3x by x to the first, 1 by x to the first. I'm going to cancel off these x's, these x's, these x's, these x's. What's this going to go to? 0. That's going to leave me 0 minus 2 on the top. What's this going to go to? 0. Just going to give me 3 on the bottom. Do you see it working out? Don't do it like that ever. All right, I just wanted to show you because you're at a level where you can understand stuff, how to work it. All right, let's go to this page. So this is what you were taught in pre-calc, and this is what we're going to stick to. Because your limits at plus and minus infinity are really the horizontal asymptote. So we're going to keep that going. If the degree on the numerator is less than that on the denominator, mainly what that means is the denominator will take over. What you always going to tell me the answer is? 0. Yep. If the degree of the numerator is equal to that of the denominator, regardless of what else is in the problem, if that is highest on the top somewhere and on the bottom there's a minus 4x to the 99th and it's the highest, what's that going to go to? The coefficients, negative 3/4. And let's just do it that way and call it good, because honestly the long way muddles it. If the degree of the numerator is, this is the one twist we have to do. We have to add a little calc insert to the last one. If the degree of the numerator, and let's suppose that the numerator is negative x to the 13th, is greater than the degree of the denominator. Let's suppose that was negative 10. And let's suppose that we're approaching negative infinity. When you were asked this in Algebra 2 and pre-calculus in the horizontal asymptote question, you would say, oh, there isn't one, right? I don't know what they'd have you write, but did you write none or isn't one or something? But graphically, what does that mean is happening here? Where's it going? To the infinities, right? But with calculus, you have to decide which one. So yes, this is going to the infinities, but you have to decide if it's this one or this one. Is it going up or is it going down? That's just a little sign analysis. Let's go take a look. When I put in a negative number, because I can't put in infinity, it's a destination, but let's put in a negative number. What's the negative to the 13th going to be? Negative. But there's a negative out front. So the top's going to be positive. What's the bottom going to be? Positive. So you need to give it a little more depth than how you're used to answering. You just can't say doesn't exist or there isn't an asymptote. You have to tell me where it's going. But other than that, we're going to cruise through these. Are you ready? Number 9. You should immediately, let's not do any calculus for number 9. Why? Why make it messy, right, Benny boy? So, number 9. Where's the highest power? Where's the highest power, Benny boy? Bottom. So where's that going for sure? To what? Go ahead, man. 0. Exactly. So this limit is 0. Done. It's as easy as that for that one. If I ask you for the horizontal asymptote, you'll say the horizontal asymptote is y equals 0. All we're doing is putting a limit layer to something you already know. Let's go to the next one. It's all about who's biggest. We always just say, you know what, you guys aren't doing enough to affect this problem. It's the big guys. And they're tied. So what's my answer? 4/5. That's the limit. What's my horizontal asymptote? Y equals 4/5. Done. All right, let's go to the next one. All right, the top is taking over, so that's going to head out of control. It's not going to have the bottom reining it in and sending it to 0 or canceling everything out. The top's taking over. It's going somewhere. So you need to decide where it's going. So you need to pick a pot. This isn't doing anything. You need to pick a positive number and throw it into the biggest parts of the top and the bottom. The top's going to be positive. The bottom's going to be positive. Where's this going? Positive infinity. So basically you disregard everything except the highest powers. The calculus method of doing number 12 is a mess. So let's not do that. Let's attack it with common sense. Let's even go way back to elementary school. What they tell you, when you divide by a fraction, multiply by the reciprocal. Our book would not approach this one that way, but we're going to. If I multiply everything through by x, I'm really taking the limit as x approaches infinity of 4x squared minus 5x cubed plus 3x. And let's use some common sense, okay? There is no denominator to look at. Actually, its highest power is 0. I mean, it's not doing anything. But I still go and have this guy, the highest power, be in control. Does that make sense? So, when I put in a big number, where is this highest power going to send this function? Negative infinity. Exactly. In, I think, Algebra 2, I think they call this end behavior. Does that sound familiar? That's really what we're doing. So we're putting just a little calculus twist on something you almost know all of. Not everything. Like you wouldn't have had one like number 13, but we can tackle it. Number 13 is a little different. Here's why. First of all, you're gone and you're gone. You're not the highest powers. It's kind of like me saying, Olivia, you just won $2 billion. Should be sweet. And I said, no, you won $2 billion and $4. But you're not gonna go, whoa, 4 more. You know what I mean? This doesn't matter. It's these things. We have to be a little careful about what you think the square root of x squared is, because what you think it is and what it actually is are probably different. What have you always been told the square root of x squared is? It is not x. What? It's not x. You've got to be very careful with that. Because watch, the square root of negative 6 squared is really the square root of 36. And if I were to ask you what's the square root of 36, what should you tell me? 6. It's not plus or minus 6. And I said, what? I've always been told plus or minus. No, you weren't. You were told that when you're in the process of solving something like x, and just watch, plus 1 equals 26, you subtract 1, and you get 25, and you have to root here. That's when you get plus or minus 5, because they both work. Doesn't that make sense? Right? But you weren't told that the square root of 100 is plus or minus 10. You weren't. Right? What's the square root of 100? 10. All right. So the square root of x squared actually is not x. This is 6. What math operation takes things that are negative or anything and makes it positive? Absolute value. The square root, the reason you're not taught that, I wouldn't either. Honestly, if I was teaching Algebra 1, which I have, I never told them the square root of x squared was the absolute value of x. Because for their purposes, it didn't matter. You know what I mean? But for your purposes, this totally matters because it affects the signs of things. So this is what you're going to do up here. You're going to go clean this up, and you're going to focus on the fact that the square root of x squared is the absolute value of x. The bottom is still 2x. Those are still tied. They're both x to the first degrees. Once you do this, you actually have a 50-50 guess. It's either a half, right, or negative a half. That's all you have to do, because you know it's the coefficients because they're tied. Here's how you decide. You go and put positives in. If you put positives in here, the top is positive. If you put positives in here, the bottom's positive. So where is this going to go? 1/2 positive. Now watch, the next problem looks identical. Note the difference though. What did I change in number 14? It's different from 13. What did I change? Negative infinity. So you're still doing nothing. You're still doing nothing. The top, you're still the absolute value of x. Or if you don't want to write absolute value of x, at least in your head think it's always positive. Okay? On the bottom, this is still 2x. Here's the only difference in my thought. The top is still going to be always positive. What's the bottom going to be? Negative. Where's this one going? Negative. Do you see the difference? It's just a little bit deeper level of thought, but for the most part, it's this I've already told you. All right, so I want you guys to go try number 1. I clicked this off an actual AP test. It says the line y equals 5 is a horizontal asymptote. One of these has a horizontal asymptote at 5. You might not know some stuff about some of the others, but it doesn't matter because you should be for sure about one of them. Just glance through them. You might be like, I don't know. But then you'll be like, oh yeah, that one's 5. Go circle it when you're like, yep, that one's found. You got it. Yep, you got it. You got it. I'm just going to check these 2 rows. You got it. You got it. Go ahead and see it. Use your rules with the highest powers, and one of these has to go to 5. You ready? Let's take a look. You might be like, I have no idea. Then move along. You might be, oh, this is actually a line. That's unbound everywhere. See, that one's out for sure. This one you might be like, oh, maybe. But what's happening on this one? It actually really doesn't matter, but it's good for good conversation. What is this? It's 1 over x, moved 5 to the right, and it's going like this. It certainly doesn't have a horizontal asymptote. Plus, the denominator's taking over. Where's this one going? To what? Where's this one going? As x goes to infinity, because that's what a horizontal asymptote is. As x gets huge, what's this going to? 0. That goes to 0. As x gets huge, what does this one go to? -5. That was close, but no good. As x gets huge, what's this one going to? There it is. What's this one going to? I don't know and I don't care, because I just found the one that did. Does that make sense? How many of you had that? I walked out here and I saw most, but I didn't get everywhere. All right, so I put this one on to mess with your head, number 2, because you got to be very careful. Here's what most kids nationwide would do at this point after having the lesson you just had. My teacher said I look at the highest power. It's on the top. My teacher said that means it's unbound, or there's infinities there, so it's got to be E. What an easy question. And it's, be careful about what your teacher said. Those rules I just gave you today are for when you approach what? Infinity. When you approach a constant, you plug the constant in, right? And in this one, you get 0 over 0. And then you should definitely not circle this one. I did not tell you 0 over 0 is 0. What did we do in this scenario yesterday? I don't need to create. Right? Yeah, I factor. Who said that? Yeah, Keegan, exactly. I factor it to kind of figure out what my issue is and get it out of there. So when I factor that, I get a 2x cubed. Pulling it out, I get x cubed plus 3. There's my top, all nice and factored. My bottom, I can pull out 3 more x's. I can now see what my problem is. I'm going to cancel it off in just a second. It'll be 4x squared, right, plus 1. Now I'm going to cancel, just like we did on yesterday's. These are going to go, right? Oh, plus 3, thank you. Yes, and it'll matter. So now that I'm done, what do I do? I just canceled off something. That something was probably what was causing my problem. What do I do now? Plug the 0 in again. Yeah. So when I go now, plug the 0 in. Notice how bad my notation is today. It's because for these problems, it doesn't matter. And all it will do is slow you up, and you'll lose track of what you're doing. So it's, again, I told you yesterday, this is one of the few couple days where I say do them as fast as you can accurately, because I'm good here. I've got 2 times 3 over 0 plus 3. What's my answer? 2. So this one I put on there just because you got to be careful what you're approaching. We're not going to do the next one because it's got, my proctor made the graph wrong when she typed it in. I want you to go to do number 4. I want you to do it quickly without writing anything down and 100% accurately. I have so refined how I teach this lesson because you can be 100% accurate without applying much calculus. Where are the highest powers? What do you do? And circle the answer. You ready? So I'm going to pick on you, Joe. Which one did you circle? He picked B. Is he right, guys? Yeah. Why is it B? Because you don't matter. You don't matter. It's the highest powers. I steal their coefficients. -1/4. Some of them are as easy as that. It's definitely not E. They won't put her on your test. My proctor threw that in there to be fun. It said D and E, and she threw that in. Like, thank you. All right, go do that one on the left. It should be almost as fast without any angst or any calculus or anything muddling the issue. You look at what you're creeping on. It's not a number. I can't plug it in. Infinities are all about highest powers. And Maddie's got a half, right or wrong? Totally right. Ignore all this, coefficients. Now, a little bit trickier. Okay, so these are how you did it last year and the year before, just a little bit of a twist. We're not calling it a horizontal asymptote anymore. We're calling it a limit. We're throwing in some roots, but still, I would approach the same way. Get the superfluous stuff, the non-highest powers out of your brain. Don't look at it. Okay? Then go do what you can. Square root of 3, no clue what it is. Goes on forever, never repeats. ACT alert right now. They'll have you classify that kind of a number. What's a number that goes on forever and never repeats called? Irrational. Yeah, that's just a little ACT blurb. The square root of x squared, what did I tell you that is? Absolute value of x. Be careful of calling it x. Okay? You can in your head go, it's always positive, that'll work too, but I like the absolute value. On the bottom, I have a negative 2x. At this point, you're down to 50-50. Here's why. These are tied in power. They're both x to the first. So it's either this, right? Or positive. It's one or the other. You have to do a little sign analysis. You are putting positives in for x. So let's go do that. The top will be what? What's this going to be? Positive root 3. And when you put positives in for x, what's this going to be? Negative. All right. You might say, well, yeah. Well, the next one's the same problem. What's the difference, though? Well, yeah, so watch. You just can't be sloppy. You still ignore this. You still ignore that. Square root of 3, no clue. Square root of x squared, absolute value of x. On the bottom, still, negative 2x. They are still tied, but I would say 9 out of 10 dentists will choose negative root 3 halves. Right? Yeah. Haven't you ever heard that? 9 out of 10 dentists approve crust for their oral hygiene needs. 9 out of 10 students would circle root 3 over negative 2 because they see coefficients tied and they think those cancel, but you got to be careful. You got to watch where you're going. This top will be positive, right? What's this going to be? This will also be positive because whatever x is, it's negative. It will cancel, but these two are going to be, this and this are going to be opposites. So you might even want to write plus, minus, so you can look at the sign of it. This is actually positive root 3 out of 2, and only one dentist chose that, right? So go try the next one on your own. Actually, just staring at it, these are so nice to do this method. I feel so bad for the first group of kids I ever taught because I didn't do it this way. And it made the lesson so hard. And it need not be, right? We don't do things just because that's the way the book does them. Let's take the best one. All right, so you should be down to a 50-50 guess, right? Just by looking at it, if you get what I'm talking about, who's my two options? Negative or positive 3, right? Because these are gone, this is gone. I've got a negative 3x and an absolute value of x, which really has a coefficient of 1. The powers are tied, so it's either negative 3 or positive 3. How do I pick? I put my negative in here. The top will become what? Positive. The bottom will be positive. So what's my answer? Positive 3. So there's a little, we're done. Here's what you're going to do. You have half an hour. The first thing we're going to do is take up yesterday's worksheet and do one of them together. Actually 2, but just because you're my last class, I know the ones that are going to get you. They're both on the back. I'm stealing. Sorry, Olivia. I'm swiping yours. Here are all right, we're going to do number 4 on the last page and numero 8. Those are the two that popped up this morning for kids who got that far. All right, now I can hand this back. Here you go. So, for this page up at the top, there's some directions. It says, part A, find the limit as x approaches negative infinity. So for part A, and you can just write the answers just off to the side of the problem. There's plenty of room. You don't have to show any work, really. For part B, it says have x approach infinity. For part C, it said write the equation of any horizontal asymptotes if they exist. So here we go. We're going to go do number 4 together. Okay? On number 4, I'm taking the limit as x approaches negative infinity. I immediately get rid of all non-highest powers. Okay? Then I look at what's left, and I notice the top is just going to crush the bottom. That means that there's only 2 possible answers. What are they? The infinities. Now you have to decide, and that's where that's where the little refinement. You used to just write there isn't one. I'm not going to do that anymore. We're going to know exactly which infinity it's going to. Because I'm approaching negative infinity, I'm going to do a sign test. What's this going to be? When I do a negative number to a 7th power and then triple it, the top will be going down. Okay? The bottom, when I put in a negative and square it, right? It's going to be what? Positive. And if you want a picture using negative 99 or something, that's fine. I just think, okay, I got negatives going in here. That's going to be negative. Now I can answer the question. Which infinity is it going to? Positive infinity, and I'm done. So the next one for letter B of number 4, you're supposed to approach positive infinity. Well, what does that mean? The top is going to be positive, right? But this is going to be what? Negative. That one's going to go to negative infinity. So you do need to kind of have a little bit of thought. Horizontal asymptotes for number 4, there aren't any. So you just go ahead and write none. It's unbound on both sides. If you were to graph it, you'll see it heading like this, like straight up and straight down. For number 8, it's got the same thing. You're supposed to approach negative infinity first, and then you're supposed to approach infinity. You don't have to write this down. I'm just giving you the, and then horizontal asymptotes. In order to do that, I need to clean her up. I'm going to just get rid of all non-highest powers in every one that you do. Non-highest power gone, non-highest power gone. I'm going to clean up the top. I know the square root of 9. It's always been 3. It's not plus or minus 3. It is 3. The square root of x squared is what? Absolute value. Thank you. On the bottom, I have a negative 2x. That's what I'm going to be plugging stuff in. I actually know the answer, sort of. I just got to figure out who's which one, right? What are the 2 possible answers for this when we're tied? Positive or negative 3/2. To make that decision, I have to let x be negative for a moment. The top will still be positive, right? What's the bottom going to be? When I approach negative infinity, what's the bottom going to be? Positive. So I'm going to be positive on the top, negative 10, positive on the bottom. This one's positive 3/2. When I approach infinity, this is going to be positive. This one's going to be negative. So this is the one, and that's negative 3/2. I think that's the best way to approach these. What are your horizontal asymptotes? Y equals plus or minus 3/2. If you were to graph it, you would see up at 1.5 and down at 1.5. Your function will be bound. It probably does something like that. Or I don't know. I'm not going to graph it. So flip the page over. Yesterday there was a spot where it said stop. I would like you to pick that up. Common sense rules the day. So let's go do a couple just with common sense because we can. Number 20, what's the limit of 6 everywhere? What's the limit of 6 everywhere? 6. Number 29. Negative 2x is controlling the show, so ignore the 11. Where's that going to go when x approaches infinity? Or, common sense, that's a line going downhill. It's going straight down. You know what I mean? We use a lot of math sometimes that's just not necessary. I know what the graph of it looks like. Why bother? All right, and then 30 together and we'll be done. Who's running the show on number 30? 3x to the 4th. Don't let anything else go into your brain. I know it makes either a W or an M graphically, right? So when I put in a negative and I raise it to the 4th, what do I get? Positives. Where's that going? Positive infinity. We're done with that. See what I mean? They can, if you've got the thought down, you'll crank those out pretty quickly. I'm going to stop this.